Okay, hello again, students. So as you can see now, we're looking at the single photon interference apparatus, and we have the top off. As you can see, this is why I was calling it the tube or the channel or whatnot. So let me just tell you what's inside now. So if I go down to the power side here, you can look in there and see sort of just a bit of a circuit board in there. Really nothing you need to touch in there, but you can just sort of see where, for example, the dimming knob and the power supplies and so on are connected. This is the little interlock switch right here that ticks on and off. That would get tripped. That would trip off the power to single photon detector if the lid was off. Okay. As we move down just a tad bit here, you see our two light sources. This is the laser source right here. It's a small laser diode inside this small metal can. This is the incandescent bulb that we'll be using. There's a lens here to give a little bit of collimation on the way out. And basically the device is sort of interchangeable in terms of what you want to use. Like for instance, if you turn the laser on, which it is right now, and you can see the beam on this card right here, then it's sort of magnetically connected. You can just sort of slide the laser over and that'll center down the optical path. But we'll just push the laser out of the way because we're not going to use it in this experiment, as I know you've already done laser-based interference in some of your other labs, maybe optics or introductory physics. So we'll just focus on the incandescent bulb. And if I go ahead and turn the bulb on like this, and maybe I'll turn the knob there up as far as it goes so you can see it on the card here. And if I hold this little piece of paper in front of it, maybe like right about here. I don't know if you can see that or not. It's very dim because this is for the single photon bit. If you look very, very carefully at the paper, I don't know if you can see it, there is the faintest little green light on that piece of paper. And so that's the incandescent bulb with a green filter in front of it. And you can read about what the green filter is for in the documentation. Okay, but anyway, those are the two light sources. So we'll have this on, and so the photons from the incandescent bulb will stream down the tube, and the first thing that they'll encounter here is a lens. It's just a small lens right here to give us a little bit of collimation here, a little bit of an aperture right here. And now as we go down a bit more, this is where that first micrometer is here, and hopefully you can see that there's another lens in there, and it's actually where the double slit is. And you can take the double slit out and replace it with a single slit or slits of different parameters. We'll just do one fixed double slit. And of course, if I turn this knob here left or right, it'll take the double slit and move it left or right across the channel here so you can center it over the light source. I have that already pre-centered and optimized, so I'm just going to leave that at the moment. And that's exactly what you would do once you had that sort of set and optimized. You wouldn't change it anymore either. And then, of course, the last piece is a little more relevant to us in our data that we'll take when we go to the other end down here. You can see pretty much the same looking setup in there. You have the micrometer again. Again, the light can just keep streaming down the channel here. You have the micrometer right here, but now that's connected to that very small slit that allows you to analyze a portion of the interference pattern that you get. So again, the light's coming down the channel. The interference pattern is generated in the double slit, which is right here. So the interference light is going to start heading down the channel this way, start heading down. So it gets all the way down here. And for example, you might get a central maximum right here where the pencil is, a minimum over here, and then sort of we would spread laterally across the tube. So you can turn this micrometer to change the so-called analyzer slit left or right to just selectively allow what portion of the interference pattern you want to go into the detection system, which is, of course, in that big box right behind us there. So that, in a nutshell, is it. As impressive as the device is, it's mostly empty, just sort of a space for light to travel down with some electronics on that end, the laser or light bulb, collimator, double slit, and all the way at the end, the analyzer, and, of course, the single photon counter sitting there, ready to tell you how many photons you've received. So in the next video, I'll turn it on a bit and show you how it behaves.